Each patient turns to his doctor with the confidence that he will get the best possible advice and therapy. But how confident can the doctor be about his decision without sufficient information about the patient? Wouldn't it be nice to know immediately the functional status of the heart, digestion, brain, or even neurological status? With an overview of hormone levels, oxidative stress level, or even blood gases and the acid-base balance. Or to follow the effectiveness of the recommended therapy, and to get early warnings in case side effects arise. What's more, all of these within 3 minutes with a non-invasive procedure? French scientists have developed a system called electrosomatograph to help you. The electrosomatograph is a computer-based functional diagnostic device that uses a process called chronoamperometry, based on the equation of Frederick Gardner-Cottrell. By measuring the current flowing through an electrolyte volume, the ionic concentration of the components can be precisely calculated. The human body contains at least 60% water. This water is located in different compartments of the tissues. 2/3 of the total body water is inside each cell. Most of the remaining 1/3 is the interstitial fluid, and the rest is the plasma. As cell functions maintain and regulate the homeostatic balance of the extracellular fluid, any disturbance in this equilibrium is a consequence of a cellular dysfunction or pathology. The tissues constitute an electrolytic medium. The conduction of the electrical current is assured mainly by ionic carriers. The values of the level of the various compartments are different, and ESG uses DC current impedance so as to measure only one compartment, the interstitial fluid. The system has 6 electrodes, and out of these, always just 2 are used at one time. Through the active electrodes, ESG introduces low-intensity electrical signals, 1.28 volts direct current, into the human body. This is totally painless and has no damaging effects. In order to locate the organs in dysfunction, the human body is divided into 22 volumes, as measured by 6 electrodes. Modeling and localizing the different organs and systems is based on a sophisticated mathematical foundation. Within the 3 minutes of measurement, ESG collects information about the ionic composition of each part of the whole body. Organs and systems being examined are displayed in a dark blue color. On the right side of the screen, the height of the bars are proportional to the conductivity of the different volumes. After 3 minutes, the measurement is completed and the computer evaluates the data in seconds. Evaluation of the results starts with a generic overview. On the left side of the screen is shown a 3D model of the human body, where different colors highlight the metabolic and acid-base balance of the organs. The columns on the upper half of the right side represent organ systems. The height of the bars is proportional with the estimated degree of risk to the particular organs. Now we will go through the findings of a real measurement recorded earlier. The first column represents the respiratory system. ESG reports the possibility of respiratory disorders, bronchi or asthma, hypoventilation, and hypercapnia. This patient had a predisposition to upper respiratory tract inflammation. The biggest risk is with the gastrointestinal system. ESG indicates the possibility of digestive inflammation, especially around the stomach and in the region of the small intestine. ESG suggests digestive examinations are necessary. The next bar represents the immune system. Risk of autoimmune disease. Increase in production of immunoglobulins, especially IgG. The next one would be the risk of degenerative diseases and cancerous attacks, but in this case no risk is shown. The next column is for the urogenital system. ESG recognizes possibility of interstitial nephropathy, but as the column is low, the disturbance is not severe. In case of follow-up measurements, it would be worth checking the evolution of the condition. Evaluating the musculoskeletal system. ESG indicates lumbar pains due to a vertebral blocking with misalignment of sacroiliac joints. The consequence is an unequal load on the joints of the lower extremities. The cardiovascular risk is not high either. ESG indicates possibility of hypertension of neurovegetative or hypothalamic origin. Self-measurement is recommended for a diagnosis of hypertension. The evaluation of the central nervous system shows possibility of stress and possibility of neurovegetative dystonia. We can even get information about the neurovegetative tonus of the internal organs. ESG provides further options. Information on lipid and blood sugar levels. So liver enzymes together with certain hormone levels can be obtained. ESG is the first non-invasive method to determine Astrup parameters, as illustrated in the Davenport diagram. It comes from physiological studies that each pathology has a representing metabolic consequence, which enter the Astrup values into a certain region of the Davenport diagram. As seen, different segments of the diagram characterize specific pathologies. As the metabolic status is different due to hypertensions of different origin, ESG evaluation might advise whether the patient has, for example, renal or thalamic hypertension. ESG also provides evaluation of the applied therapy. For example, in case of hypertension, the message could be that the treatment is appropriate or insufficient, and that the treatment regime should be modified. One of the biggest advantages of the electrosomatograph is that it makes the doctor able to monitor the effectiveness of the applied therapy. There is the possibility to display simultaneously the evaluation of two different visits, and any change becomes easily recognizable. For example, in case of oncological therapy, a sharp change in the acid-base balance represents therapeutic effectiveness, and also helps to determine the best timing of repeated doses. On the other hand, a lack of this pH change means that the therapy is not effective and that a different protocol should be considered. After discussing with the patient all the risks he has with the particular organs and systems, the doctor checks the list of supplementary examinations proposed by ESG and decides what further examinations and medical therapy he recommends. Findings and the recommendations can be printed out and handed over to the patient. The 3D graphic interface and the printout of the summary of the medical checkup significantly increases the patient's compliance and motivates the patient to attend medical checkups